In this problem, we use a mole to describe a collection of atoms, ions, or molecules which numbers 6.022 times 10 to the 23rd. If you had a dozen chocolate chip cookies in your cookie, you would have a cookie that contained 12 chocolate chips. Whereas if you had a mole of chocolate chips in your cookie, you would have 6.022 times 10 to the 23rd chocolate chips in your cookie. Yum! In part 1 of the problem, we calculate the length of a chain of carbon atoms in meters if 1 mole of them was arranged in a continuous straight line with each atom end to end, given that the radius of a single carbon atom is 70 picometers. In the second part of the problem, we know that the speed of light in a vacuum is 3.00 times 10 to the 8th meters per second. That's the rate, how fast the speed of light is moving. How long would it take that light to travel the length of this carbon chain, given we have a mole of them connected, assuming, of course, they're in vacuum? So let's begin with the first part of the problem. I think it's helpful to draw a little picture to help us think about our carbon atoms lined up in a row. So I've drawn these circles to represent carbon atoms, and we imagine them continuing 6.022 times 10 to the 23rd of them, and we want to figure out what that length will be. We know that the radius, which is from the center of the atom to the edge, is 70 picometers. So we know the distance from one end of a carbon atom to the other end is going to be twice the radius, or the diameter, 2 times 70 picometers, or 140 picometers. So our length is really the diameter of that carbon atom times the number of carbon atoms lined up. Diameter times Avogadro's number. Or 140 picometers per carbon atom times 6.022 times 10 to the 23rd carbon atoms. So we get a length of 8.43 times 10 to the 25th picometers. Now let's convert that to meters. So we know that there are 1 times 10 to the 12th picometers in 1 meter, or 1 times 10 to the negative 12th meters is 1 picometer. So 8.43 times 10 to the 25th picometers divided by 1 times 10 to the 12th gives us 8.43 times 10 to the 13th meters. Now let's move on to the second part of our problem. Here we want to think about how long does it take for the light to travel that distance. So we know the speed of light is 3 times 10 to the 8th meters per second. So 8.43 times 10 to the 13th meters divided by that speed gives us 2.81 times 10 to the 5 seconds. Let's convert that into a more useful time unit. 2.81 times 10 to the 5th seconds divided by 60 seconds in a minute gives us 4,684 minutes, divided by 60 minutes in an hour gives us 78 hours, or 3 1/4 days. A long time, even though light travels fast, because it's going a very long distance. For more details about the math used in this problem are given in the attached math modules. There's also additional practice problems at the end of this unit.